Okay, that's apparently mine. How do I get this thing to go away? Oh, close. Let's try it. There we go. Okay, good morning. Hare Krishna. Welcome. Today we are continuing our Richard L. Thompson lecture series. Today we are on, this is our sixth session. It's a hard one. Yeah. Chapter 5. In our last session, Prishni gave a presentation on Chapter 4, Karl Popper and the Mind-Body Problem, a review, where Richard L. Thompson critiques Popper's concept of emergent evolution and suggests that it raises more questions than it answers. He offers an alternative to Popper's rather vague reductionist notion of self, in which consciousness itself is an inherent feature of reality and not an emergent property. And today we have the pleasure of introducing Dvija Govinda, who will give his second presentation in the series on Chapter 5, Information Theory and the Self-Organization of Matter. He has a PhD in both acoustics, computational mathematics, and works as a telecommunications specialist at the scientific and production enterprise Delta SPE, and has been teaching Vedic mathematics and other courses in Kiev Krishna Consciousness Academy since 2013. Welcome, Dvija Govinda. Thank you so much for being with us. You may go ahead.
Thank you very much for your kind introduction. So today we are discussing the summary of Chapter 5 of the Mechanistic and Non-Mechanistic Science by Richard Thompson. The title of the chapter is Information Theory and the Self-Organization of Matter. Information Theory and Self-Organization of Matter. So, one of the most interesting chapters of this book. It may appear quite sophisticated with mathematical formulas, but nevertheless, the main idea is quite simple. And this is a brief outline of the chapter. There are 4 items, 4 paragraphs in this chapter. The first, a theme of simplicity in the theories of physics. Then the great complexity of biological form. So this is the main contradiction, which will be pointed out by Richard Thompson here. Then theoretic limitations on the evolution of complex form. And finally, complex form and the frustration of empiricism. So, in fact, there are 3 or even 2 main points which are significant to understand the message of this chapter. The first one is that variegated forms of living organisms possess a high information content. In other words, even the simplest simplest organisms like cells, primitive cells, they are quite sophisticated in the sense that they represent themselves as connection of different molecules of various types, etc. And there are many possible combinations of such molecules, and that is why it is said that these organisms, even the simplest ones, possess a high information content. Later it will be more clear what is meant by this term, high information content. On the opposite, what Richard Thompson states, that the laws of nature and corresponding mathematical models of physical reality can all be described by a few simple equations and other mathematical expressions. It means that these physical laws have low information content, in contrary to the high information content of the variegated forms of living organisms, which are supposed to appear due to the action of due to the dynamics of the physical laws, which are known to the current state, to the current science. So, and this makes a contradiction. Basically, this makes a contradiction And the third point is that configurations of high information content cannot arise with substantial probabilities in models defined by mathematical expressions of low information content. If I have a very simple law, very simple some physical or mathematical rule, and I have some finite period of time, I cannot expect that due to this law, due to the action of this law, very sophisticated, very I don't know how to say, very complex form will arise. This is what Richard Thompson wants to stress in his message presented in this chapter number 5. So these are two main points which should be understood, and then the other is the details of how Richard Thompson presents it. So even the simplest cell, the cell of not even a human, of animal, or even of some primitive organism, has these cells have quite complicated structure, which is known from biology, biochemistry, etc. And what the author is dealing with is a very simple organism. This is well known Escherichia coli, or E. coli. This is some organism which is often found within human beings and other or animals anywhere. So Escherichia coli is a unicellular organism which has a very small size, about 500 times smaller than the average cell of higher plants and animals. This is Escherichia coli. Hope I pronounce it correctly. I was training with Google Translator. Hope I pronounce it properly. So also it is known that it contains from 2,000 to 3,000 different protein molecules, of protein. So different molecules of protein constitute the cell. Not only of them, but basically each Escherichia coli cell contains several thousand thousands of protein molecules. And what can we say about protein molecule? Every protein molecule contains about 300 amino acids. This is a chain of 300 amino acids, which each of them could be of 20 types. Each of them could be of 20 types. It means that there are 20 to power 300 variants of such protein molecules. Okay, this is a huge number, 20 to 300. It's about 10 to 400. So it's 1 with 400 zeros. Very huge number. But to deal with it more simply or more conveniently, we take a binary logarithm. This number, binary logarithm, and it's quite natural. So we find by taking binary logarithm, we estimate the number of bits which are necessary to store all the possible variants of protein molecules by taking binary logarithm. It's quite natural. For example, if we have, let's say, English alphabet, which I believe 26 letters. Yes, 26 letters, and if we take binary logarithm, we get about something 5.5 bits. So 5.5 bits is necessary to represent the symbols of English alphabet. Yes, and corresponding here we have 20 to 300, huge number. But if we take binary logarithm, we obtain about 1,297 bits of information, or 1,300. Let's say 1,300. About 1,300 bits of information are necessary to represent the protein molecule inside the Escherichia coli cell. Okay, but But there are at least 2,000, as we said before, such molecules. It means the total information content. Total information content, it's abbreviated here as TIC. So the total TIC is about several million bits, from 2.5 to 3.9 millions of bits. This is a quite big information content only of one small cell. Yes, only. So it may be used in, I don't know, some future biocomputers or something like this. So each Escherichia coli can represent such amount of information. Okay, from 2.6 to 3.9. Also, I would like to, how to say, possibly I would like to skip some of the details, but I will shortly present all what is said in the chapter, all main points, although some of them are not crucial for the final result, but nevertheless I will mention. Also, Richard Thompson estimates not only total information content of a cell, but also a genetic information content. Genetic information content, which is represented here as GIC. What does it mean? It means that each E. coli cell contains at least one chromosome, which consists of circular molecules of DNA. In other words, we have in each cell the DNA molecule. DNA molecule, it contains the coded instructions that defines the structures of all other molecules in the cell. And this genetic information content is also, I will not say about all of the details, but basically the Richard Thompson estimates the upper limit for this genetic information content of E. coli cell. It's about 5.5 millions of bits. It's quite the same order. We get about 3 million of bits for the total information content. For genetic information content, we get about 5.5 millions of bits. So it's quite close numbers, and I don't think it's quite essential. Yes, we can use either of them, I believe. But this is upper limit. In fact, the genetic information content of a cell will be lower than this number. But how much lower? It's essential, and especially essential for all other derivations in this chapter, to understand the lower limit, not the upper limit, but the lower limit from the bottom, for the genetic information content of a cell. But now the author switches from Escherichia coli to mammalian cell. Mammalian cell is said to be of a size about 800 times bigger than the cell of Escherichia coli. So correspondingly, we multiply the upper limit by 800, and also we need to estimate the lower limit for the genetic information content of mammalian cell. And many pages Richard Thompson dedicates to get this number, 600,000 of bits. This is a low limit for the genetic information content of mammalian cell. But very briefly, I can explain following his logic that the lower limit of 600,000 bits would mean that if, for example, if this information content would be lower, it would mean that less than 16 bits are required to represent the information content of each of 440,000 protein molecules inside the mammalian cell. And 16 bits is underestimation, a total underestimation. It's too few in view of what was said before. So 600 bits, it's very, very pessimistic, let's say, lower limit for the genetic information content of mammalian cell. And this number, especially not all these numbers, 5 million, 3 million of bits, this number will be used in the following inferences or following logic of this chapter. We have to memorize just this number, 600,000 bits is the lower limit for the genetic information content of mammalian cell. And the question in the following will be, can the present laws of physics lead us to such information content of a mammalian cell? Would these laws of physics be complex enough to produce the mammalian cell with such information content? And the answer will be negative, but we will see how the author pursues this goal. So it's quite interesting logic. But what Richard Thompson says, that physical laws are quite simple, he states, and they can be programmed by a relatively low amount of computer codes, of software codes. Yes. For example, he says that 6 pages. He takes 6 pages of computer code as the upper limit of for example, some gravitation for representing of gravitational or Maxwell equations. I will not comment it at this point. I believe, of course, if the author states so, he has it's substantiated. He has some. In Ukrainian, we say to have a ratio under this. I don't know if it's translated adequately in English. So it's, I believe it's rational, but nevertheless, 6 pages of the code of symbolical representation of high-level computer code are enough to represent the basic physical laws. This is what states Richard Thompson here. Each page is said to contain 2.8 thousand of symbols. Symbols meaning like A, B, C, D, multiply, division, semicolon, etc. So there are 64 such symbols. 64 means 6 bits are required for each symbol. I believe it's a mistake. In the bottom from my side, it's not 6 symbols per bit, but 6 bits per symbol. Yes, that's my mistake. So if we multiply it, we get the information content of such software to be 100,000 and 800 bits. 100,000 and 800 bits, or let's say 100.8 thousand bits. This is the information content of software describing the some basic physical laws. The author does not concretize, does not define exactly which laws are meant, but previously at the beginning of the chapter he mentions some gravitational or equations or Hamiltonian principle, something like this. Well known, the laws of physics which are known to the modern science. So let's step one step back. So we got 600,000 bits for the information content of very primitive mammalian cell, and in fact the information content will be higher. This is a low limit, but the higher limit for the basic physical laws is said to be less than 100,000 bits. So they differ in 5 times, but it's not really necessary that in 5 times, but the difference between them in half a million bits is essential. And now this formula I will not much comment it. It follows from the paper which was published by Richard Thompson in the authoritative magazine, which is called Pattern Recognition, in 1980. But nevertheless, I cannot skip without saying something about this formula. What this formula does say? What does it say? That this formula defines the upper limit for the probabilities that some particular configuration, let's say molecular configuration, described by code code, which is called here M, that this configuration will take place. Molecular configuration will take place if we make modeling with some model which is defined by model M, which has information content, some other color, which has information model, which has information content LM. And LX is the information content of this molecular configuration. So the formula is quite logical. It means that when the information content of molecular combination increases, the total number, the total probability decreases exponentially. If the information content of the code or the software code increases, then the probability correspondingly Px will increase exponentially. There are some empirical constants. I tried to go through the paper, and it's not easy to understand how the author gets them, but nevertheless, here they are. The constant C is equal to 326, T is 10 to 51 degree. So, nevertheless, let's take it for granted for the moment, and let's go further. How we take advantage of this formula? We can calculate. We can calculate that the mammalian cell, the probability of mammalian cell to be obtained due to the dynamics of the known physical laws. And this number, if we substitute, if we substitute all the previously obtained numbers to get this probability, we will have some, I don't know, infinitesimal number, very small number, 10 to power minus 150,000. So infinitely small number. I'm not sure I could say correctly. Infinitesimal, yes, in English. So in fact, it means that it cannot be reached practically. It cannot be achieved, this configuration with the information content of 600,000 bits. It can be obtained. It can be reached by the dynamics of a model which has information content of 100,000 bits. And this is the basic result of this chapter. What was everything what was previously said was to lead to this main result, to get this very small number as a probability of obtaining such a complex structure as a primitive mammalian cell. Yes. So even although it's very primitive in our sense in comparison with other types of cells, but nevertheless it is complex enough to be produced by the physical laws. This is the main conclusion which is made by the author in this chapter. Someone might say that quite complicated mathematics. There are too many logarithms, some empirical constants, and some more simple logic may lead to the same result. Yes, it's also true. I will say a few words of how it can be reformulated in an alternative way. First of all, as we see here, this formula presents 2 to power some Lx minus Lm. No, minus Lx plus minus Lx plus Lm, and both these L's are produced by binary logarithms, because it's information content which is also was calculated through the binary logarithms, but 2 to power binary logarithm by the base 2 of x is equal to x. Yes, so everything possibly can be much simplified without taking to so much logarithm, etc. So there is some alternative logic which also could be followed, and I want to mention it. It is presented in the Origins magazine, published by Dvija, I believe, in 80s, the 80s of the previous century. I was mentioned the main idea. I believe also that Richard Thompson was also the author of this technique, which was presented in this magazine. So let's come back for a moment to recall that each protein molecule contains of 300 amino acids of 20 types. As a result, using just multiplying these possible variants, we get a total number of variants about 20 to power 300. It means that the probability to find a protein with a given structure of given sequence of amino acids is about 20 to power minus 300. It means about 10 to minus 400 degree. Minus 400 degree. 10 to minus 400. Very, of course, small number. But some, even if we make some such some concession in the sense that the author refers to a paper by Hoyle and Vikramasinghe, who said, researchers who said that the sequences of some sequences of amino acids may vary. The sequence of amino acids may vary without a significant violation of the properties of protein molecules, and this probability can be increased, much increased, to be 10 to power minus 20. So in fact, that huge upgrade, huge increasing of this probability, but nevertheless it remains quite a small number to find some protein molecules with a particular structure of amino acids. But it was already said that 200, at least 200 protein molecules are inside one cell, such a cell as Escherichia coli. Here we again say about Escherichia coli, not about mammalian cell. Even if we speak only about Escherichia coli. So the total probability to find a simple cell of Escherichia coli which contains about 2000 protein molecules is 10 to power minus 40,000. 10 to minus 40,000. But if we would assume that which is not typical, but that Escherichia coli would contain only 100 protein molecules, then the probability of finding in nature of such a sequence of amino acids, total combinations of amino acids would be 10 to minus 2000. 10 to minus 2000. And can we obtain with some physical permutations since the time of, for example, of origination of Earth, of formation of Earth, 4.5 billions of years, such a cell, yes, which could be found, which exists, the existence of which has such low probability? And the answer is negative, but the author proposes such an experiment. Let's suppose that the surface of the Earth is covered by primordial soup, which has a depth of 1 kilometer. And during 4.5 billions of years, there are some chemical reactions or permutations of primitive chemical elements, and there is 1 billion of reactions per second in each cubic angstrom of matter. Angstrom is something like the size of the hydrogen atom. And taking into account all this, the total number of such reactions would be less than 10 to 74. So it's 1 with 74 zeros. I tried to reproduce this number and found that yes, very close. I got the 7.2 multiplied by 10 to 73. It's almost the same which the Richard Thompson gives in his paper. So, but again, the probability of getting the simplest cell, yes, with 100, just with 100 protein molecules, would be 10 to power minus 2000 multiplied 10 to 74. And it remains the very small number. Very small number, 10 to minus 1926. So infinitesimal number again. Infinitesimally small number again. And even if we would multiply this number, if we would assume and it is said that if we would assume that all these experiments with primordial soup will be held in the number of planets, on the number of planets which equals to the number of particles, elementary particles in the universe, which is 10 to 88, even then it would be very small number. We just have to add summation here plus 88, but the total number will remain again. It will have almost no influence to the order of this very small number. And so the probability of reproducing a very primitive cell due to, by the random accidental permutations of chemical elements, this probability is almost zero. It's almost nil, I would say. But also the author mentions that there is no logical sense, there is no common sense to talk about probability of obtaining of such probability of obtaining some primitive cell due to the sequence of reactions since the time of origination of Earth. Because we can talk about probabilities only when we have some repetitive events. For example, dropping a coin or something like this. When we have some sequence of events which are systematically observed, we can compare the theoretical value obtained of probability with the value actually observed in the experiment. But here we cannot do this. We cannot run again the whole sequence of permutations of chemical elements since the origination of life on Earth. Maybe it can be done in different universes, but here we again come to the idea of Everett with multiple bifurcation of universes. I don't know. Maybe we should not go so deep in this. So again, the main conclusion is again the same. The idea of the chapter or of this simplified presentation, which was in the Origins magazine, the main idea is the same, that the systems with low information content, with high information content, cannot be produced by mathematical models which have low information content. This is the main idea of this chapter. So let me just repeat these main points. So intricate and variegated forms of living organisms possess a high information content. On the contrary, the laws of nature and the corresponding mathematical models of physical reality are presented by simple equations, simple mathematical expressions, which are supposed to have a low information content. And this makes a contradiction. We can show that configurations of high information content cannot be or cannot arise with substantial probabilities due to the dynamics of the models which have low information content. And this is the main idea of chapter 5 of this book. Thank you very much for your kind attention. I hope you did not get tired of my broken English and etc. But nevertheless, I'm full of admiration of the great amount of work which Richard Thompson did in producing this great literature, scientific literature, which has value both from the view of material science and spiritual science as well. Thank you very much for your kind attention.
Thank you very much, Dvija Govinda. That was wonderful. I certainly needed that explanation because this chapter in the mathematics just make your eyes go twirly. Are there any questions or comments? We'll open it up now. Okay, Brahmatirtha.
Hey, Dvija Govinda.
With
I
acceptable
apologize. I
basis.
had to miss the beginning. I had to give a class in India to a Bhakti Shastri class, and it was scheduled a long time ago. So I will listen. This is a very important chapter to me, so I will listen to the first part on recording. One question that often comes up is this, and maybe you discussed it already, but the mathematical odds are infinitesimal. But if there's infinite number of universes, then we happen to be in the universe that the math worked. And, you know, the multiverse has now become very popular, and you have the issue of, you know, the quantum mechanics and string theory and more dimensions and more universes. Plus, it says, even the Bhagavatam says Lord Vishnu breathes, and infinite universes or innumerable universes are coming out. And now with the Webb telescope, we're seeing so many galaxies we didn't know exist. Each galaxy has many bigger than the Milky Way. And so the answer to the statistics is, well, you have an unlimited number of universes, and this is the one that worked, and that's why you and I are talking to each other.
So this is some kind of anthropic principle. Yes, the weak formulation of anthropic principle.
Yeah.
But excuse me, Brahmatirtha, what is the question? So while
the question is, mathematically, it's highly improbable. But if you have, but if you have billions and billions and billions of universes, then mathematically it becomes possible to happen in one of those universes, and we happen to be living in that one. And the proof is I'm talking to you now.
Yes. So, but it's not a question. Yes, I understand. This is just a statement.
Yeah. So what's the response to that?
How can we respond to it?
Yeah. Oh, I see. Prishni is raising her hand to help.
Yeah. Yes, I
please.
Thank you. Just last night, I was listening to a lecture by Sadhaput. I know the number. If you want to look it up on the website, it's 077. But he discusses this exact thing, and he makes the comment, which I thought was just lovely. He said, if you're satisfied with this kind of explanation, then go for it. That's what he says. Because if you're not satisfied with this kind of explanation, which, you know, he implies that most reasonable people won't. If the only way you can explain it is that there's unlimited universes where this stuff is going on, and so it just happened, that is such a stretch. And go for it if you're happy with that. That's actually what he said. Because it mathematically can be explained that way, but why Occam's razor, of course, would be, and that actually points out, wouldn't it be a lot easier just to assume some kind of intelligent design? If you're going to, if you're going to take this thing where there's infinite numbers of universes and all this stuff's going on simultaneously, or you could say, as men have for the last many thousands of years, there's clearly evidence of some intelligent design. Why would you pick that one? Oh, no, there's no intelligent design. It's actually billions and billions of universes. Okay, there it is.
Okay, thank you.
Yes. For me, it proves this statement of, this is a weak, as I understand, this is a weak anthropic principle, which states that we just happen to be in one of the billions of universes where mathematical laws are such that we're situated here posing these questions, but this proves nothing. This is just some kind, not fruitive, not fruitive starting point, but there is a strong anthropic principle, which perhaps you well know about it, which says that there is some underlying idea behind this universe. In fact, this is the idea of creator, as far as I understand, but which is which is formulated in very vague way, not direct, in indirect way. There is some idea behind this universe that the universe is designed. There is this underlying principle under the universe, so that finally all the physical laws stimulate the development of consciousness, the development of conscious living beings. And as far as I understand, this is strong anthropic principle, and it says about creator, about intelligent design behind all of this. But weak anthropic principle that we're situated just in, or maybe in some corner of the universe, where such, only where the life is possible, not satisfactory. It's just not fruitive, not useful. Just agnosticism, I would say.
Well, here's the deal with that argument is it's not a scientific argument to say it's an argument for chance. And that's not a scientific argument. Another thing is, how does he know someone making that statement, how do they know all these other unlimited universes don't have consciousness in them? He's gone and tested them all. Maybe they all have consciousness in them. You know, how do they know that the appearance of chance is not by design? I mean, so this is a deeply philosophical question. So even if there are millions and millions of universes, and this is the only one with consciousness, how do you know that's by chance? Maybe there's some God who just likes, I just like having a lot of empty space. I don't know. You know, so you know, you could say that, but it still doesn't conclusively prove chance as a ultimate absolute metaphysical conclusion. So you can say anything you want, you can't test it scientifically. So conversely, you can't prove intelligent design, but it really comes down to just making a reasonable argument and then let people take it from there. We're just trying to provide some shelter and safe space for people to cultivate bhakti.
Well said.
Trying to make the jnana favorable.
Well said.
I have I want to, Dvija Govinda, I have something from the conclusion in the book that I'd like to share for the group, and then just maybe a simple comment. So towards the end, he's speaking about the conclusions, and he says, if nature is indeed simple and comprehensible, then it is hard to imagine any other method of studying nature than the empirical method of experiment and calculation. But by showing that nature may not be simple, we are opening up the possibility that there may be other valid methods of obtaining knowledge. If the absolute foundation of reality is a reservoir of irreducible and inconceivable qualities, then the possibility arises that we may be able to approach the absolute by methods other than dissection and measurement. Our empirical analysis of evolutionary theory cannot prove rigorously that this is so, and it cannot disclose how such an alternative approach could be practically realized. However, it does show that empirical reasoning is capable of pointing beyond itself. I found that interesting because it doesn't throw away empirical reasoning. It's just saying there's something further. I guess my question is, so from what he says in your presentation, technically there isn't such thing as a simple organism. That's what was described by the E. coli. And my question is, how is it, other than this idea of chance, how is the complexity of all the organisms explained without the metaphysical? Are there any other theories other than this happened by chance? I guess that's the question.
Yes, I think I understood your question. In fact, I don't know what maybe other modern theories which could explain such variegatedness of organisms. Maybe some of you could tell. I'm not familiar. I'm not familiar with other possible ones, other possible theories. Basically, there are two alternatives: theory of chance and the theory of intelligent design. And if we are frustrated with the chance theory of just random permutation of chemical elements, we must assume the presence of some intelligence behind it, which means personality. I don't know. I'm sorry. This is all that I want.
You can do science. You can do science. You can do science either way. I mean, but science itself, as a profession, is just going to examine it as far as just as if it were chance. They're not going to say, well, the leprechauns did this and the elves did that. We're just going to be, looking at it in terms of things we can describe as cause and effect that could be mathematically quantified and so forth. Now, it could all happen by chance in some ultimate metaphysical sense in theory, or it could, or maybe there's some designer. But you have to be careful about intelligent design, because the big weakness of some of these institutional outfits promoted, it's intelligent design as far as they consider what could be intelligent. And I mean, if there's some god who's intelligent designing, his intelligence is so far beyond anything a human being could imagine. So it's not that some human intelligence is capturing, oh, this is proof of what God can and can't do. So there's two paths you can go by, that everything's by chance and therefore I can just have a party, or everything's by design and therefore I could just have a party with Krishna, but science can be done either way, but these larger philosophical questions are beyond. Yeah, I think Leela brought up, I mean, empiricism can bring you to the point of realizing the self, realizing that you can get to a certain point where you can realize empiricism isn't everything. I think that was the line you quoted there.
Yeah, and interested. Thank you for that, Steve D. So towards the end, he says, if it is to be of real interest, such an approach to absolute knowledge must be verifiable by tangible, reproducible experience, for otherwise it amounts to nothing more than empty speculation. So I found that interesting too, because he's giving all the formulas and the empirical evidence of something, and then he's saying we have to go beyond this. So kind of showing it, taking it to the limit, and then saying there's got to be more. And I just found this interesting, because what would that look like? Verified by tangible, reproducible experience. If it's not in the empirical, say in the formulas in this particular data, then what does he mean by tangible and reproducible experience?
Well, one thought that comes to mind is like different. This is Sadaputa quotes?
Yes.
Okay. Well, one thought that comes to mind is that we say, just do the experiment. You take up the process of bhakti and become purified, and you realize more and more about Krishna. So that's not going to be like a lab experiment in a test tube, but you apply yourself to these principles, and you will get that experience. I mean, the Acharyas seem to be saying that, and devotees who haven't blue seem to confirm that they're getting that a little bit, at least a little bit. People like the Six Goswamis have articulated intellectually ad nausea beyond me in Sanskrit. So you can play with it empirically. We can get, but whether that can be proven in somebody's lab according to disciplinary criteria of physics or something, that's another thing.
Yeah.
That's not the only reproducible experience.
Yeah, so the self itself becomes the laboratory, and the
Got it. That's the
empirical
real
proof,
game. The rest of this stuff is static by comparison.
right? And then the empirical proof is just the individual experience of the person that can be reproduced if we all follow the one process.
Yeah. Well, the empirical proof, the direct experience, and the direct experience isn't limited to empiricism. Empiricism is a subset of that, because right now we're conditioned by these senses. human beings. We call that empirical. What we can see with these senses is reality and toto encapsulated by that limited experience. We even in our subamones, they say, how's that possible? So, but apparently the soul is not limited by present sets and so on and so forth. But science itself will be limited to things that can be reproducible empirically, because that's their, shared experience. But even then, the scientists, you have to be highly trained to understand their results. So it's not like everybody can just see what they see. They look at, some thing that comes, they're trained to see it. I mean, and someone can look at a car, and they can see, oh, the alternator needs to be fixed. Someone look at a car, there's a bunch of crap in there, I don't know what's going on. So, just seeing things, what does that mean? You have to be trained and learn to yada, yada, yada. So when HTG says it's really philosophical questions, he's got a point there. How we analyze these things.
Yeah, absolutely true. Thank you very much. Any other questions or comments?
I would just like to shortly add, I think it's relevant to the question which you raised, Alina, that we do not reject the empirical science, of course, as it is. This is a quote from the end of chapter 3. The general measurable phenomena generated by non-mechanistic entities can be at last partially described by an open-ended hierarchy of mechanistic theories of ever-increasing complexity. There is no lack of available subject matter for mechanistic theorization. So here Sataputa Prabhu says that we do not reject the empirical approach as it is, but it should be augmented, enhanced by other kind of knowledge. Knowledge which can be, as Sita Muni Prabhu said, perceived by direct experience. Okay, I just wanted to say this one.
Yeah, I could say just one thing. This is all reminding me a little bit of the seminal work done by Dear Govinda, David Wolf, with his Mahamantra experiment, which was done very scientifically, actually. But he did it by reporting and recording subjective reports. So he would, he had a whole list of questions that he'd give the participants in the experiment before they did the Mahamantra chanting. And then he'd get answers after a week of Mahamantra chanting. And then he had he had the one group doing nothing and another group doing some other mantra chanting, wasn't the Mahamantra. And when you read that kind of study, it is a study. It is empirical in this sense that the person is reporting what it is that he's experiencing. So you can get a subjective experience into an empirical experiment by just ask the person, what is it? What are you feeling right now? What did you see that was different? Yeah. And that's one way to do it.
Yeah.
Yeah, but then ultimately it'll be interpreted by people who read that.
Yes.
So and then that's where you get into the larger philosophical issues. For a theistic person, yeah, it's very supportive and faith inducing, if you will. For someone who's a hardened atheist, it says, well, it's just all in the mind.
Yeah, that's an interesting point, because, for example, with if I tell you of something that happened to me, it's an anecdote. If we get 100 people and they tell you something happened to them and it's the same thing, now it becomes data. Now it's some kind of research. So at what point does the subjective become empirical, that we can actually look at it and say, look, these are all similar experiences that people are having? And why is that? Is it or is it not accepted as empirical when you collect it and organize it in that way?
Well, sociology is not really a hard science.
Well, I mean, right, but I mean just the example of, like, say, our subjective experiences of an absolute truth. If I tell you about it, it's an anecdote. If all of us are sharing that experience and telling about it, at what point does it become verifiable data, even though they are still subjective?
Right. There's nothing about science that's ultimately absolutely verifiable. Everything's open to challenge. New data, new evidence comes in. So again, this is a criticism of some of these institutionalized intelligent design initiatives. They will insinuate that claim strongly because we have our people, we've all did our science. It must be true. But real science, real science, at least as a discipline, it's always falsifiable. It has to be falsifiable. Of course, scientists are human beings, and some of them are hardened atheists in a very religious way. And maybe they'll say that, but they don't feel it. And they believe in science. So that's a whole different issue. That's scientism. Anyway, so again, you get back to HEG. When you say philosophical issues, there's really a lot to that. There's science, ideology, and worldview. That was my dissertation.
I think we need to bring up then the work of Gopinath, who, using David Wolf's, Dear Govinda's work, actually did measurements on heart rates and that kind of thing. And now we're getting much more into the realm of non-subjective. If you say, okay, this person can say, boy, I feel a whole lot better. Or you can connect all these electrodes to them, and you can tell by their heart rate thing and that thing that they probably do feel better because of this, physical data. So you can, that's being done. I think Kunal's doing something similar with puts electrodes on people's heads, and you can actually get data that way, right?
You can, but does that prove Krishna is God? Or does that prove that just repeating something over and over has a calming effect?
Well, he did try it with blind. Yeah, they both of them.
Well, maybe has he tried all potential word combinations?
No. So no, of course not. But you do see that the Maha Mantra has a certain effect, which is vastly different from having no mantra or having some other mantra. That's pretty clear.
In his subjective test, so it suggests that there might be something going on with the Maha Mantra. It has a calming effect. Great.
That's yeah. But it's
there's some efficacy there. So that's great. So I'm just saying, from a scientific perspective, hard science, it just shows this combination of words has some calming effect in the heart rate. Isn't that nice?
Yes.
So that's nice. Now, from a devotional perspective, as well, he's that kind of faith-inducing. It's a little bit more effective empirical evidence than saying Coca-Cola.
These guys actually, though, talk to Dear Govinda about, he actually gets whole conferences of PhDs chanting the mantra to experience for themselves the effect. So it has, it's improved, but as you said, it's wow, look at this. People are going to go, oh, let me try that. That's all.
Yeah. So it's good that way.
So it's good that way.
I'm not arguing against it's not good work. It induces faith. It attracts people to take up the process of bhakti by hook or by crook.
By hook or by crook. Okay.
Say.
Yeah.
But but from a hardened science perspective, it can be readily argued in many ways, but we can engage it. It's very engageable science. How's that?
These things, both Dear Govinda and Gopinath got their results published in prestigious peer review journals. Both of them did, different journals.
That's great.
I think clinical medicine. Yeah. So there, it is rigorous enough that it passes the peer review test. Which is,
but I'm not saying that's good. I'm saying that's good. That's good. Yeah. But it doesn't conclusively prove anything other than it got published in a peer review as a credible study.
There you go. Okay.
Yeah, so that's good. And then it opens up all these people to try it. So, and maybe there's something here. People come to the Sunday feast not like because I want to, taste Krishna's saliva and experience bliss. They might come because, hey, man, it's kick-ass food and there's really good music. And then we rope them in.
Yeah.
You know? So same thing, only with the intellectual energy in a different form.
Great. Thank you very much. Any other comments or questions? Otherwise, we will close. Okay.
I want to thank Dvija Govinda. I'll listen to the first part, but thank you. I hope everything is going okay for you in Kiev. I can't imagine all the tension. And you did give my regards to Zelensky, I hope.
I already.
Oh, very good. Okay. Very good.
And he also
sends back. Okay, that's
regards to you.
Very good. Okay.
Great. Thank you very much. Okay, so we will, thank you, Dvija Govinda, very much for taking the time to explain this chapter and the discussion. Thank you all for your comments and.
I just thought a joke. Can I share a joke? Can I keep it
Yeah,
real?
yeah, of course.
Well,
go
back
for
in the
it.
Civil War, they had this thing called Beecher's Bibles, right? It's like these preachers up in the north, they'd send cases of Bibles to like Missouri, because there was this contest between the free state people and the slave, but there were really cases full of whatever, AK-47s, but they were packaged as Bibles. They did fundraising at the, so we can send Brahma's Bhagavad Gitas or something to Kiev. Maybe we should think. I don't know.
That's great. That's a good idea. Okay. We'll need funding for that. Okay, so please join
We'll
us.
do a fundraiser.
Yeah, a little fundraiser. So join us in 2 weeks, Saturday, April 29th, for the presentation on the next chapter. It's chapter 6, Chance and the Unity of Nature, given by Krishna Narasimham. He's an electrical engineer who served on the TOVP team from 2008 to 2010, and he currently works in the automotive industry. So we're going to continue with this book. Thank you very much. We will upload this to our YouTube page along with the other lecture presentations that have been given. Have a good weekend and Hare Krishna.
Hare Krishna.
Krishna.